Welcome to Limitless Math. Today we're diving into one of the most fundamental concepts in geometry, the types of angles. Understanding angles is essential for success in geometry, trigonometry, and countless real-world applications. An angle is formed when two rays meet at a common point called the vertex. The rays extend outward from this vertex, creating the opening we measure as the angle. There are four main types of angles you need to know. Each type is defined by its measurement in degrees. First, we have acute angles. These are sharp, small angles that measure less than 90 degrees. Think of the angle in a slice of pizza or the tip of an arrow. Next are right angles, which measure exactly 90 degrees. These form perfect corners, like the corner of a book or the intersection of perpendicular lines. Obtuse angles are wide and open, measuring more than 90 degrees but less than 180 degrees. Picture an open book or a reclining chair. Finally, straight angles measure exactly 180 degrees, forming a straight line. This is like a flat horizon or a completely open door. Understanding angles is crucial for many fields and standardized tests. Architects use angles to design stable buildings. Navigators use them to plot courses. Engineers apply them in mechanical designs, and artists use them for composition and perspective. In the following sections, we'll explore each angle type in detail, learn how to identify them, and practice with real-world examples. By the end of this series, you'll be confident in recognizing and working with all types of angles. Acute angles are the sharp, small angles that measure between 0 and 90 degrees. These are angles smaller than a right angle, and you'll find them everywhere in math problems and real life. Example 1. Let's start with a basic acute angle identification problem. Here we have an angle that measures 45 degrees. We need to determine if this is an acute angle. Step 1. Check if the angle measurement falls within the acute angle range. We know that acute angles measure between 0 and 90 degrees. Step 2. Since 45 degrees is greater than 0 and less than 90 degrees, this is definitely an acute angle. Notice how sharp and pointed it looks compared to a right angle. Example 2. Now let's compare multiple angles. We have three angles, 30 degrees, 75 degrees, and 95 degrees. Which of these are acute angles? Step 1. Let's check each angle against our acute angle criteria. Remember, acute angles must be between 0 and 90 degrees. Step 2. The first two angles, 30 and 75 degrees, are both acute because they're less than 90 degrees. The 95-degree angle is obtuse because it's greater than 90 degrees. Example 3. Here's a more challenging problem. In this triangle, we know two angles, 90 degrees and 35 degrees. We need to find the third angle and determine if it's acute. Step 1. We'll use the triangle angle sum theorem. The sum of all angles in any triangle equals 180 degrees. Step 2. Set up the equation. We have 90 degrees plus 35 degrees plus our unknown angle equals 180 degrees. Step 3. Solve for the unknown angle. 90 plus 35 equals 125. So our unknown angle equals 180 minus 125, which is 55 degrees. Step 4. Since 55 degrees is between 0 and 90 degrees, this is an acute angle. We successfully found that the unknown angle is 55 degrees and it's acute. Example 4. Real-world application. An architect is designing a roof with a steep pitch. The roof makes a 25-degree angle with the horizontal. Is this an acute angle, and why might this be important for construction? Step 1. First, let's verify this is an acute angle. 25 degrees is definitely between 0 and 90 degrees, so yes, it's acute. Step 2. In construction, acute roof angles like this create steep roofs that are excellent for shedding rain and snow quickly. This prevents water damage and structural problems. This shows how acute angles aren't just abstract math concepts. They have real practical applications in architecture, engineering, and construction that affect our daily lives. Obtuse angles are wider than right angles, measuring greater than 90 degrees but less than 180 degrees. These angles appear wider and more open than the angles we've studied so far. Example 1. Identify which of these angles is obtuse. This is our simplest problem to build your understanding. Step 1. Look at each angle measurement. The acute angle is 45 degrees, which is less than 90. The right angle is exactly 90 degrees. The obtuse angle is 120 degrees. Step 2. Since 120 degrees is greater than 90 degrees but less than 180 degrees, this is our obtuse angle. Notice how it appears wider and more open than the others. Example 2. Find the measure of angle x if we know that angle x plus 60 degrees equals 180 degrees. This is a medium difficulty problem involving angle relationships. Step 1. We need to isolate x. Subtract 60 degrees from both sides of the equation. Step 2. Simplify both sides. The 60 degrees cancel out on the left, giving us x equals 120 degrees. Since 120 degrees is greater than 90 degrees, but less than 180 degrees, we have successfully found an obtuse angle. Remember, obtuse angles are always between 90 and 180 degrees. Example 3. In triangle ABC, angle A is 30 degrees and angle B is 25 degrees. Find angle C and determine if it's obtuse. This challenging problem combines triangle properties with angle classification. Step 1. Remember that the sum of angles in any triangle equals 180 degrees. Write the equation. Angle A plus angle B plus angle C equals 180 degrees. Step 2. Substitute the known values. 30 degrees plus 25 degrees plus angle C equals 180 degrees. Step 3. Simplify the left side. 30 plus 25 equals 55, so we have 55 degrees plus angle C equals 180 degrees. Step 4. Solve for angle C by subtracting 55 degrees from both sides. Angle C equals 180 minus 55, which is 125 degrees. Step 5. Determine the angle type. Since 125 degrees is greater than 90 degrees, but less than 180 degrees, angle C is obtuse. This makes triangle ABC an obtuse triangle. Example 4. An architect is designing a modern roof. The roof makes a 135-degree angle with the horizontal wall. Determine if this is an obtuse angle and explain why this design choice matters. This real-world application shows how obtuse angles appear in architecture. Step 1. Identify the angle measurement. The roof makes a 135-degree angle with the horizontal wall. Step 2. Classify the angle. Since 135 degrees is greater than 90 degrees but less than 180 degrees, this is an obtuse angle. Step 3. Explain the architectural significance. Obtuse angles in roof design allow for better water drainage, create modern aesthetic appeal, and provide more interior space compared to acute angles. This is why architects frequently use obtuse angles in contemporary building design. We've explored obtuse angles through 4 progressive examples: basic identification, algebraic calculation, triangle geometry, and real-world architecture. Remember, obtuse angles are always between 90 and 180 degrees, appearing wider and more open than right angles. A straight angle measures exactly 180 degrees and forms a perfectly straight line. This is one of the most fundamental angle types in geometry and appears everywhere in math help and exam prep. Here's what a straight angle looks like. Notice it forms a perfectly straight line, just like a ruler laid flat on a table. A key relationship to remember: a straight angle equals 2 right angles added together. That's 90 degrees plus 90 degrees equals 180 degrees. Let's start with our first step-by-step example. Here's the problem we want to solve. Identify which of these angles is a straight angle. Step 1. Look for the angle that forms a straight line. A straight angle will have its 2 rays pointing in exactly opposite directions. Step 2. Verify it measures 180 degrees. Angle B forms a perfectly straight line, so it's our straight angle. Example 2 increases the difficulty. Here's our problem. 2 angles form a straight line. One angle measures 65 degrees. Find the missing angle. Step 1. Remember that angles on a straight line always add up to 180 degrees. This is a fundamental rule in geometry. Step 2. Set up the equation. 65 degrees plus the unknown angle equals 180 degrees. Step 3. Solve for the unknown angle. Subtract 65 from both sides. 180 minus 65 equals 115 degrees. Example 3 is more challenging. 3 angles form a straight line. The first angle is x degrees, the second is 2x degrees, and the third is x plus 30 degrees. Find x. Step 1. Since these angles form a straight line, their sum equals 180 degrees. Set up the equation. Step 2, combine like terms. X plus 2x plus x equals 4x. So we have 4x plus 30 equals 180. Step 3, solve for x. Subtract 30 from both sides, 4x equals 150. Then divide by 4, x equals 37.5 degrees. Be careful. A common mistake is forgetting to distribute or combine terms correctly. Always double-check your algebra. Our final example applies straight angles to real life. A surveyor needs to measure property boundaries. Two property lines meet at 180 degrees to form a straight boundary. If one section makes a 73-degree angle with the boundary, what angle does the other section make? Step 1. Recognize this as a straight angle problem. The property boundary forms a 180-degree straight line. Step 2. Apply the straight angle rule. 73 degrees plus the unknown angle equals 180 degrees. Step 3. Solve. The other property line makes a 107-degree angle with the boundary. This ensures accurate surveying measurements. Remember these key points about straight angles. They always measure exactly 180 degrees, they form straight lines, and angles on a straight line always add up to 180 degrees. These concepts are essential for exam prep and solving geometry problems step by step. Example 1, clock angles. Here's our first real-world scenario. We need to identify the type of angle formed by clock hands at 3 o'clock. Notice we can see the hour hand pointing to 3 and the minute hand pointing to 12. Step 1. Identify the angle formed. The angle is between the hour hand pointing right and the minute hand pointing up. We can see this creates a corner-like shape. Step 2. Measure the angle visually. The hands form a quarter turn, which is exactly 90 degrees. This is our key clue for identification. Step 3. Classify the angle. Since the angle measures exactly 90 degrees, this is a right angle. Remember, right angles are the only angles that measure exactly 90 degrees. Example 2. Architecture. Here's a more challenging scenario. We need to identify multiple angle types in a house roof structure. Notice we have different roof slopes and a chimney creating various angles. Step 1. Analyze angle A. This is where the roof meets the wall. The roof slopes upward at about 60 degrees from horizontal, making this angle less than 90 degrees. Step 2. Analyze angle B. This is the peak of the roof. Since the roof slopes are equal, this creates an angle of about 60 degrees, which is also less than 90 degrees. Step 3. Analyze angle C. This mirrors angle A, also about 60 degrees. All three angles are acute because they're all less than 90 degrees. Common mistake. Don't confuse the steepness of the roof with the angle size. Example 3. Sports analysis. Here's our most challenging scenario. We need to identify multiple angle types in a basketball shot. Notice the player's arm position, the ball trajectory, and the hoop angle all create different angles to analyze. Step 1. Arm angle. The player's shooting arm forms about a 45-degree angle with their body. Since 45 degrees is less than 90 degrees, this is an acute angle. Step 2. Launch angle. The ball leaves at about 45 degrees above horizontal. This is also acute since it's less than 90 degrees. Step 3. Peak angle. At the highest point, the trajectory changes direction, creating about a 120-degree angle. Since this is greater than 90 degrees but less than 180, it's obtuse. Step 4. Entry angle. The ball enters the hoop at about 45 degrees downward. This is acute. Key insight: trajectory angles help players optimize their shots for better accuracy. Example 4. Art and design. Our final real-world application involves perspective drawing. Artists use angles to create depth and dimension. We need to identify how different angle types create the illusion of 3D space on a 2D surface. Step 1. Analyze convergence angles. Angles A and B show how parallel lines appear to converge toward the vanishing point. These acute angles create the illusion of distance. The smaller the angle, the farther away the object appears. Step 2. Corner angle analysis. Angle C, where the building's front and side meet, is obtuse, about 120 degrees. This obtuse angle makes the building appear three-dimensional rather than flat. Key insight: artists strategically use acute angles for depth and obtuse angles for dimension. Understanding these angle relationships helps both in creating and analyzing artwork. This demonstrates how geometry directly applies to visual arts and design. Now we'll explore the essential tools for measuring angles accurately. From traditional protractors to modern digital technology, these tools are crucial for precise angle measurement in math and real-world applications. Example 1, using a traditional protractor. Here's our first angle measurement problem. We need to measure this angle using a standard protractor. Step 1. Position the protractor. Place the center point of the protractor exactly on the vertex of the angle. The baseline of the protractor should align with one ray of the angle. Step 2. Read the measurement. Follow the second ray to where it intersects the protractor scale. This angle measures 30 degrees. Always read from the correct scale. Use the scale that starts from your baseline ray. Example 2. Measuring obtuse angles. Now we'll measure a larger angle. Notice this angle is greater than 90 degrees, so we need to be careful about which scale to read. Step 1. Position the protractor correctly. The center point goes on the vertex, and we align the baseline with the horizontal ray. Step 2. Read carefully from the correct scale. This obtuse angle measures 120 degrees. Common mistake. Don't confuse the inner and outer scales. Always start counting from your baseline ray. Example 3. Digital angle measurement tools. Modern technology offers precise digital alternatives to traditional protractors. These tools often provide more accuracy and additional features. Step 1. Open your angle measurement app. Many smartphones have built-in tools, or you can download specialized apps like Angle Meter Pro or Smart Protractor. Step 2. Utilize advanced features. Digital tools offer precise decimal readings, automatic calculations, and can save your measurements. Some even use augmented reality to overlay angle measurements on real objects. Example 4. Real-world construction application. In construction, precise angle measurement is critical for structural integrity. We'll see how modern tools help ensure accuracy in professional settings. Step 1. Position the digital inclinometer. In construction, workers use digital inclinometers to measure the angle of beams, ensuring they match architectural specifications exactly. Step 2. Verify precision requirements. Construction projects often require accuracy within 0.1 degrees. Digital tools provide this precision, while traditional protractors might only be accurate to the nearest degree. This precision prevents structural problems and ensures building codes are met. Let's recap the essential tools for measuring angles. Whether you're using traditional protractors or modern digital technology, accuracy and proper technique are crucial for success in mathematics and real-world applications. Remember these key points. Always align the protractor center with the angle vertex. Read from the correct scale. Digital tools provide superior precision for professional work. Practice with both traditional and modern tools to develop your angle measurement skills. We've covered all 4 fundamental types of angles in geometry. Let's quickly recap each one and see why they're so important for your math journey. First, acute angles measure between 0 and 90 degrees. They're sharp and pointed, like the corner of a slice of pizza. Right angles measure exactly 90 degrees. They form perfect corners, like the corner of a book or a square. Obtuse angles measure between 90 and 180 degrees. They're wide and open, like an open laptop screen. And straight angles measure exactly 180 degrees. They form a straight line, like a ruler or the horizon. These 4 angle types are the foundation of geometry. Mastering them now will make advanced topics like trigonometry, calculus, and engineering much easier to understand. To master angle identification, practice looking for these angles in everyday life. Use a protractor to measure angles you find. Try estimating angle sizes before measuring them. And remember, angles appear everywhere in architecture, sports, art, and technology. Understanding angles is your gateway to advanced mathematics. Whether you're preparing for the SAT, ACT, or AP Calculus, these fundamentals will serve you well. If this video helped you master angle types, please like and subscribe to Limitless Math for more step-by-step math help. Drop a comment below if you have questions or want to see specific topics covered. Keep practicing, and remember, your math potential is truly limitless.